Okay, which one of you sold your Electroneum? Alright, I know one of you did this. One of you sold your Electroneum. Was it you, Jackie? I don't know. Was it you, Billy? Billy, did you sell your Electroneum? How about you, Chico? Chico. You sold your Electroneum, didn't you? I know you did. Hey, it's Dino from Digitspin Crypto. Today we're going to talk about the Electroneum fork. How did that turn out? Additionally, I want to discuss the statement that came from Gorman. He's the director over at Electroneum. And he put out a statement. You guys have seen it on all my friends' channels there, all the other great Electroneum channels. They've told you the content. But I'm going to tell you what it all means and how it affects you. And we're going to break it down in each paragraph so that I can explain each of those paragraphs, hopefully bring you some new information and explain it all to a point where you'll be smarter and better at what you do. So don't forget to spank that like button, comment down below, because I like to respond to the comments and look for information from you guys. And absolutely, I must subscribe. Digitspin Crypto is going to bring you not only the news, but we're going to explain to you the news, and I'm going to give you my thoughts on how this actually affects each and every one of you. So that's important. Make that happen. And let's get to it. So we have a lot to discuss tonight. And in this video, we're going to talk about the fork and all the good stuff that was in the Chris Gorman statement regarding Electroneum. So let's start off with the fork. How did that turn out, Dino? Well, stick around. I'm going to tell you, because you're only going to get that information here. All right. So let's take a look and bring up some of the stats. So let's take a look at this stuff. So the good news is that obviously you can see the stitching that was happening all these different times. And as that stitch happened, it would bring that average block time up. All right. So by doing that, as we discussed, you have 740 seconds. It's supposed to be 120 seconds with the upgrade. So the good news here is that as we were going along and we were at these higher block times, you can immediately see right up above my head here where the ASICs came online, hash power shot right up. Now, since that hash power so far has been clean, see, the more level it is, the better the block timing will work. It'll have the ability to organize itself back to the 120 seconds. When you have these wild stitchings, it ends up in the middle, and then that's what causes the block time. Now, with ASICs, it's a lot harder to do that. You can't rent enough hashing power out of GPUs using the Proof of Work 7, the old one, which is what they were doing. You can't rent enough GPUs to be able to make a dent in the total hashing power when you're working with ASICs. Now keep in mind, an ASIC is about 220 kilohash. My GPUs are running probably 600 to 800. So, if you're looking at 220, so one ASIC is worth about 320 GPUs. That's kind of the ratio that you're looking at between the two. So, as you can tell, they would need a ton of GPUs to be able to cause that same type of spiking. Well, now only time is going to tell as we go along, but we're seeing some definitely people jumping on board. We're seeing the ASICs come to the place where they can mine and make some ETN, and hopefully everything will work out as advertised. I'm really happy with what I'm seeing so far. What am I seeing, Dino? Well, let's slide over a little bit. This part right here. So you can see our timing was way up there, our average time to process a block because of these swings going up and down. So now our time, if you notice, has gone back down because we have a level processing hash rate. We're seeing our block time immediately drop right back down, and you can take a look. It's right now it's in that average 145, and now it did drop down a little bit. It's actually a little bit faster at the moment because of all the buildup of all these ASICs. So once all these ASICs, because they're creating that initial wave pattern, so and then now this will stay flat as we're going along. There's going to be some bumps and what have you, but this is going to have a nice even keel and keep our block time to that 120-second range, which is really where we want this. You want an even amount that makes sure that every 2 minutes we get a chunk and it's processing. Now, keep in mind, in this fork, there's a couple of things that were left in the upgrade because they were important. One being that the block size was doubled. So, and what that does for you is, what it's going to do for you is that you're able to pack more transactions into that block to close it. And so it allows more throughput of transactions, having that larger block size. So that's an important feature that was also left back in. So all the upgrades stayed there. The second thing was the block timing. It used to be every minute, now it's every 2 minutes. And then they upgraded, since they doubled the time, they doubled the reward. So you're getting the same reward in the 2 minutes. It's just that it's done every 2 minutes. And in that 2 minutes, we can fit more transactions in that 2 minute block window. This is going to allow Electroneum to be able to process the gobs of transactions that are going to be packed in there. If you had a smaller block and you were doing it every 2 minutes, you can only fit so many transactions in the container. All right, so by enlarging the container, instead of carrying 5 pounds, I'm carrying 10 pounds worth of stuff. So now we have more information being transacted in the environment at the same time. So, Dino, can the same thing happen? You know, theoretically, it is possible. If we have 1,000 ASIC miners on there and somebody who has 5,000 ASIC miners pops on and drives it up and comes back down and drives it up and comes back down, could theoretically cause the same problem. The issue is that there's only so many ASICs so far, and the folks that are using the ASICs are pinpoint focusing in on this. It's highly unlikely that would happen. Just about everybody who has an X3 ASIC, or let me rephrase that, who has this algorithm, the Crypto Night algorithm ASIC, is pretty much jumping onto the ETN. I'm sure there are some that are keeping it for some outlying coins, but the fact of the matter is that Electroneum is going to pay them the most. So they're going to pretty much jump into that. It's highly unlikely that they'll, use it elsewhere. So you're going to see most of the ASIC power on there. Now, if you have a GPU, you still can physically mine. It's just that you're competing now with a ton of GPU equivalents. So again, for every one GPU and you have one ASIC, that's equivalent of, 400 GPUs. So it's a ton of hash power. So that's the reason why this is so far turning out. I'm going to keep monitoring it throughout the week and keep you up to date if I should see anything that looks odd or there should be any problems. But I'm liking what I see, and I hope I explained it correctly to you. There you go. There we go. That we have a nice calm block time. We have an awesome amount of of hash power being applied. And, this is all looking good. Let's get rid of that logo over there. Yeah, okay. And awesome amount of hash power. So everything is as advertised, kicked right in, and we'll go forward from there. So let me take you to the next part. Now, before I take you to the next section, I want to bring up this promo that we're going to do. What we're going to do here at Digitspin is make an opportunity for any one of you folks who want to be a guest call-in. We will record, but you will have a live, interactive webcam connection to Digitspin Crypto, and you'll be able to talk with me directly, ask questions, whatever you want to do, and we'll record that. It'll get edited, and then we'll put it into one of our videos. Now, if you want to be a special guest on Digitspin Crypto, you want to put the word guest in a comment below, and with that, leave a fun, interesting comment for me to read. And if I pick yours, we'll add you. I'll contact you, and we'll add you and set up a schedule to get you live into the recording studio, so that we can make an awesome video with you as a special guest. So keep that in mind. Okay, so all of you probably by now have seen the announcement. Most of the other ETN channels had an opportunity to get that out yesterday. Being it was the 4th of July, I was watching fireworks and eating all sorts of fun pastry things at an event at a local town. So, but I am going to have to read it, because what we're going to do here is not just read you the announcement. We're going to go paragraph by paragraph, and I'm going to explain what it means, why the things are written as they are, and how it affects you. So let's take a look at the first one. And this was the hi guys. Just to clarify a couple of points, the fork on the 30th had a number of updates, which we know what those are. Those updates were 1, changing the algorithm to proof of work 7, 2, increasing the block size, 3 was the 2-minute timing, and then doubling the reward. All right. Basically, he states in here, we had not expect such a drop in mining capacity from the 200 mega hash from the original GPUs. And they thought that this would not happen, that all the GPUs would come back in place, but it didn't. And they obviously understand those reasons. So what does that mean? So basically, what had happened when we had first started out, draw ourselves a line, we had ourselves up here 200 mega hash prior to the ASIC changeover, the original fork. And that was all GPUs that were mining away. And obviously the ASICs had got involved, climbed that up to 200 mega, to 10 times that. So they were up at 2 gigahash. All right. Now, when they did the changeover to dump them off, they were expecting this 200 mega hash to happen, but it didn't. It fell all the way down to 20 mega hash. 10 times less. Right? It's 10 times. All right. So at 20 mega hash, you still had all of these other GPUs out there that were still available but not being used. So what happens is a lot of these guys, they went to NiceHash. And when they were on NiceHash, that means that their power could have been rented. So the GPUs are plotting along, and all of a sudden, somebody threw a ton of money, a lot of money. And I'm going to tell you why I know that. I mine using NiceHash. I keep a few machines running on there. And you could tell when the individuals who were performing this function or performing this peak change, these stitching, my income on those cards would go up by at least 50%. So if a card was making $1, it would make $1.50. So they were throwing a lot of money. They were overpaying for the hash from NiceHash, and to make sure that they could grab it all. All right. So they were able to take that up to 60. All right, 60 hashes, mega hash. And when they were done with whatever they're doing, they drop it back down and let it fall back down to the 20, and then stitch it back up, let it fall back down. And this caused the timing, because the timing was going along, and all of a sudden our timing got lifted because of this stitching, because it took the top and the bottom and found its way in the middle. And because they were doing it on the 12-hour, it caused this stitching to happen. And that's what was slowing down our transactions. The blocks were not functioning as they should. All right. And so basically what Chris is explaining is that we hit this 20 mega hash as a general rule of thumb, and it just wasn't enough, because if we would have got back that 200 mega hash, somebody spiking at 60, would have only been smaller spikes. It probably wouldn't have been a big problem. And the fact is that maybe a good portion of these would not have even been available, because they would have already been allotted for in this. So that's where the problem lies. We did not get back our 200. Didn't happen. We ended up at 20. And all of these extra cards became free agents and were brought in to cause this problem. So let's clear this off, and let's take a look at the next paragraph. All right, so our next paragraph says here, we were told by many of the people, if we get past that first major hurdle, which was clearly unprofitable because of the ASICs, that the miners would go straight back on, which is what I was just showing you in that drawing. Support of the community requested we fund a lot of hashing power to get through the initial period. This is when NiceHash was renting power, basically because of all those ASICs were on board. The difficulty was so high that it took forever to get a block, because the difficulty was way up here. And so blocks weren't happening, and it was very tough. So they rented a bunch of hash power so that they could clear the blocks and make the blocks happen, so that it can then stabilize at its new natural rate, which ended up being 20 mega hash instead of the 200, which didn't happen. But they got it stabilized, and Electroneum had to spend a ton of money to make that happen, and to get through all of this. And they had to rent a lot of that same hashing power from NiceHash to make all that happen. And that's how we were able to get the difficulty down and get the blocks going again and getting everything cycling through. So that's what that is all about there, and why that happened. All right, in fairness, it happened initially over the next couple of weeks. We started to lose capacity. And so what he's talking about is that, we may have started off at 26 mega hash, but over the last few weeks, it slowly was getting down to that 20. So people were diving off of the ETN network at that time. Maybe they realized that they can get more money by going and putting their machine on NiceHash and then scooping up 150% of the power. It all comes down to mathematics of numbers and dollars. And it's a process. It's how the system works. It's designed for you to try to find a way to maximize and put your equipment in the right place, so that you can capture the biggest potential of value. It's just how it works. And unfortunately, it worked against Electroneum at the time. So, and and like I said, in fairness, they understood this. The spike started happening, and it started affecting the difficulty. And, this is a common technique that is being applied not against just Electroneum. There are plenty of other blockchains that are having these types of issues because people are finding tricks and ways to maximize their profit, and they're going to take advantage of it. If it's in the code, it's law. Code is law. And if it's allowed, it's allowed, and that's how the code works. So, others are also experiencing this type of problem. The issue is here is that Electroneum doesn't want this to happen. And that's why they were looking into a solution or had a fallback position in case things didn't work out as they expected. Now, they showed a little humility here. We don't blame the miners. It's your living, and you got to go where the money takes you. And so they understand, it's just part of the natural process of things, and it's not that it's anybody's fault. It's the situation that caused all of the timing delays. So it's an unfortunate set of circumstances, and they had to resolve it. All right. At the same time, we built and tested a red envelope rollback. What does that mean, Dino? So a red envelope rollback. Red envelope is in case of emergency, break glass. All right. All right, break the glass. Yeah, we'll hit that little glass button there. And pull out the red envelope and pop that open, and that's your backup plan. And they had it. And so what that means, and my thoughts on the matter, is that Electroneum clearly, by having a backup plan, was thinking of a possible break in the path. What happens if this doesn't work? This clearly shows me that these guys are on top of their program, understanding that things can go wrong, as they did last time. Hey, what if this goes wrong? Let's have a red envelope ready to go so that we can bang it into place right away. These guys are doing their job. The red envelope is not something that you want to do. It's something you have to do. All right. And clearly, by demonstrating this red envelope, tells me these guys are getting a lot better on their game to have a backup plan if they need to go that direction. All right. So they spent the last 2 weeks discussing it. So obviously these problems have been happening for the last 2 weeks. They obviously had their eye on the ball and discussing what they need to do. And if we want to roll out this backup plan in place, I'm sure it wasn't an easy thing for them to come up with and a decision to come up with. So they were considering the needs of the stable and fast processing, especially with what they have coming in the network in the next few months. So what this tells me is that Electroneum is clearly expecting a burst of growth to their user base. In my eyes, this is telling me that they have some plans, some interactions, some type of arrangements that they're going to be going forward with, and they see the amount of folks using Electroneum. They have probably some programs in place that they're going to announce with other companies, and to basically make all that happen, they've got to have the network running and humming to be able to handle it all. So there's obviously a couple of aces up their sleeve that we don't know about still, but they need to be prepared for. So to me, this is telling me there's some more good news coming down the line, and I'm going to be keeping my eyes peeled to see if I can find out what those things are as we go along. I'll probably make a few guesses. They spoke to a number of institutional investment analysts to gauge some of the views of the future. And so some of these analysts obviously are going to be investors not only in Electroneum, but these could be other companies that they're going to be signing relationships with, because an investor is not only somebody that just puts up fiat to buy a coin. An investor could be somebody that's going to be interacting with Electroneum, promoting Electroneum. They've got to put up hard, cold cash, all right, to do these things. And to ask another company to put an investment together when you don't have your stuff together is obviously a problem. So they have to show it that it's solid, that they got their act running before you start asking somebody else to start doing and putting their money on the line. So I would assume that those types of issues are going to be part of this. The institutional guys feel that there are many developments which could take place in the near future. And this is an important type of, this is an important part of this paragraph. And what he's talking about, there's going to be future from the progress in things like FPGAs, Intel's new mining chips, and to new companies being funded to develop the next generation of extremely powerful ASICs. So let's talk about these things because I want to make sure you understand what this all means. Let's go back to the chalkboard. All right. So as you know, most of the mining started off with CPUs. And the reason why it started off with CPUs and not in ASICs or anything else is because that's what there was. There was no software to transfer that code into a GPU to let it perform the function. You know, a lot of folks, I saw some articles and people talking, well, we shouldn't just jump into ASICs. You know, Bitcoin didn't jump into ASICs. That's correct. And the reason why they didn't jump into ASICs is because there were no ASICs. They didn't exist. The GPU processing capabilities, the software to do it didn't exist. So there were only CPUs at the time. Now, obviously, somebody figured out how to transfer that information into a GPU, a graphics processing unit, and let that part of the processor perform the function. So as that happened, obviously, the GPUs took over and kind of nudged out the CPUs. All right. And why didn't they go to ASICs then? Because the ASICs weren't available. All right. So it's not like today, if you come up with a coin, you're thrown into a midst of a storm because all these technologies are available. Bitcoin had the luxury of having these things built as it went along and inspire it and progress it in a orderly fashion so that these things could be dealt with and holes and problems can be fixed as these come out. So when you come out with a brand new spanking coin, you're thrown into the middle of a storm and you can have power thrown at you from every direction. And it's not like you have a choice. This equipment's out there. It's, you know, you invent the nuclear bomb, it's out there now. You know, before 1945, who worried about it? You were worried about a cannonball, all right? Because it didn't exist. So this is where we go along. Now, what is he talking about in that paragraph? Well, some of the things he's talking about, Intel is going to be joining into the market because right now you got AMD, you got NVIDIA, which are really the guys that are making things happen on the GPU front. And Intel's coming up with some fancy chips, and they're going to join the GPU. So now we'll have a total of 3 different companies to be able to buy GPUs from. So this is one of the things that he was discussing. One of the next things that he was discussing is that obviously ASICs are available. And what's happened is not that anybody hasn't done this already, but these are starting to be coming to the forefront. Now, believe it or not, even though we have these today, and we have these today, the FPGAs are coming in. These are field programmable gate arrays, and their processing power is going to be in between a GPU and an ASIC. It's not as fast as an ASIC, definitely more faster than a GPU. And it's been tried and tested, but the issue with this here is that they're a lot more complicated to do. And the reason is because they're programmable, just like the GPUs, because you can program these. The ASICs are not they're literally hardware designed to the program. So whatever the algorithm is, they actually hardwired all of the electronics inside to function as the algorithm. It literally is the software. The hardware becomes the software. So there's no altering it on an ASIC. Either the ASIC uses the algorithm and provides a function, and if that algorithm was to disappear, it's basically a doorstop. It can't do anything else but run that particular function. Now, the FPGA is going to give us the significant speed increase, and it looks like an oversized GPU, but the thing is that you can program it, and because you can program it, there are some algorithms that will be able to be run against it. Now, I do not know if Kryptonite is small enough to fit in there. There's only so much memory inside of the FPGA, and not every algorithm can literally be packed in there to do it. So there'll be limited algorithms that can actually run on an FPGA. I'm going to do a little more research to find out if Kryptonite is one of those. Now, the thing with the FPGA is that it's extremely difficult to program, and you need something called a stream to be able to do this. Now, there is probably a dozen people in the world that actually know how to do these things at an effectively knowledgeable way, and it's very limited. I say 12, but it really is a small amount of people that know how to literally program these FPGAs from the beginning. So as of right now, there are going to be folks that are going to write the software and make it available. I don't know if it'll be a purchase price. Plus, they'll be probably, I've seen 10 to 20% of a fee to use it. So if you make 100 coins, you're going to have to give at least 10 of those coins to the software developer of the stream. I would expect as time goes along that there'll be folks that will make some kind of a quick click software and be able to program it in a very GUI fashion to make it a lot easier. But as of right now, this is what we're stuck with. And the developer fees are just significant. But obviously, you can make a lot. Now, these things ain't cheap. You can spend easily $3,500 on an FPGA. But the good news is that if you know the algorithm changes, you can clear it and run it again. The ASIC, you've got to throw it in the garbage. There's just nothing else you're going to be able to do with it. Just toss it in the garbage. So that's the advantage of an FPGA. Now, ASICs. The current, let me tell you what he was talking about with new ASICs coming out. The current ASICs are what's called a 12 nanometer. Now, what they're trying to do is go to 7 nanometer, and they're starting to release that. Now, what does that all mean, Dino? Can you explain that to me? All right. So, a 12 nanometer is basically the distance and size of the silicone or the components that are inside the chip. So if I had a 2-inch by 2-inch die chip that is required to fit all of the processing in there, by bringing it to a 7 nanometers, I'm basically almost cutting in half the size of the components that are inside. All right, so that would allow me to have the chip that does the same thing in a 1.2, maybe 1.2 size. All right, so they made it smaller. What is the big deal? By making it smaller, bringing the components closer to each other, they need less voltage, and the thing runs faster. Because believe it or not, even though it's running at the speed of light, the distances that it has to go increases the performance. All right, so now you can have, to go from here to here, you're looking at 2.5 inches. I'm going to make this real basic. 2.5 inches, but from here to here, you're only looking at 1.5 inches. So there's a 25% pickup in distance that electricity has to travel, and you'll be able to use less electricity to make the product work. So it'll be more efficient and more effective. This is very basic. There's a lot of tech that goes into all this. And so what I'm trying to do is just to explain it in a very simple fashion of our current ASICs at a 12 nanometer, and what's being created now is 7 nanometer ASICs. So, they could easily pick up 25 to 40% increase in performance on these new ASICs. So, these are the newest concepts that are being put together, and they're actually starting to produce these here on the 7 nanometer capability. So that's what they're talking about when they say that newer ASICs are coming out, and how they're doing that to make them better, faster, and quicker. They're doing the same thing on the graphic processors. They're trying to shrink the size of the die and the components inside to be able to make them run faster. And then there's also other technology that goes along with that. But I know that AMD and NVIDIA are both working on some significant speed increases on GPUs. They have a new line of GPUs coming out that's going to pick up a significant amount of speed also. But these are the things that are in the basket, and this is what all this means when he was talking about. Let's clear this out here. What he was talking about in that particular paragraph. Okay, so their advice, these guys understand this, and they advised Electroneum that they could spend massive time and energy to constantly develop algorithms, and that may be beaten by something next week. All right, well, let's take a look at that real quick. The problem that you have, if you stay with the GPUs and you change your algorithm, it could take 3 months for them to modify. I mean, if an ASIC company wanted to make it happen, in 3 months they could have easily another ASIC that can do the new algorithm, and then they would have to take it to production. So that means if you really wanted to stay ahead of these, Electroneum would have to change a fork every 6 months. Every 6 months, they would have to fork, maybe up to a year at the max. But by a year, you're going to have new ones on there. But every 6 months, to make it a deterrent, like nuclear deterrent, to make it a deterrent, you state that every 6 months we're changing it so that they don't even bother to try to release something, because there's no sense. By the time they design it and try to get it to production, they're past the 6 month line, and it'll already be obsolete. So that's the only deterrence, and you have to actually do it. You can't say you're going to do it. You got to do it. So that means every 6 months you would have to modify your algorithm to keep it ahead of the ASIC development. And that I believe me, I want to mine with my GPUs, but that's a daunting task. There are other Monero-based coins that are going to do it. Monero itself. These guys are dedicated to make that happen. But they have plenty of GPU power that's dedicated and is constantly on the Monero block. If they were in the same position as ETN, then there may be different decisions made. But since they have plenty of folks that are actively mining Monero, they can make that change every 6 months, and the Monero community will stick with it. Now, when you're interacting with other companies that are going to be using pay systems and connecting to the environment, this is going to be a headache, because Electroneum is going to be setting up interaction with APIs and paid tablets. And now to change this, you're asking for a nightmare. Systems are going to go down because somebody in Kalamazoo didn't upgrade their node and their software. they need to have stable software out there for the environment so that everything that's going to be attached to it will have a stable interaction and connectivity to it. The throughput has to be there for them. You can't have things going down on payment systems. All right. So this is another reason why they had to have this backup plan in place and why that ended up happening. All right. Alongside the manipulation, the difficulty algorithm has increased the last few days, which is slowing the blockchain. Now, I discussed this in 2 other videos. You'll see those videos. If you go to my my page, you'll see the block timing videos on the 26th, and I discussed those in detail of what happened. That's kind of past news. While this was a difficult decision, it wasn't taken lightly. Quite the opposite. It was taken with full consideration. Listen, Electroneum knows that it was the average Joe, like myself. I'm an average pedestrian. It was the average Joe that wanted to mine this stuff, that's bringing it up, that was dedicated to it. It had to be a tough decision. I'm sure they were getting a lot of pressure from their partners to make this happen, to keep it stable and make sure that the software's not running. I'm sure there was a lot of pressure to make this happen, and because technically it's a better solution. Clearly, the reason why ETN went down this path of keeping it with the GPUs was to show loyalty to the folks that were mining it, to the average Joe, the average pedestrian like myself, like you. So it's unfortunate that there wasn't a lot of us, because if there was a lot of us, we would have had enough mining power to keep it running. And not to say it's our fault, it's just there wasn't enough of us, and so everything ended up in this direction. So basically, I've broken down the statement, which I'm sure you already have seen, but I've tried to break it down in a way that you can understand what each of the paragraphs were about, why these things happened, and I hope that it gave you a little more insight, made you a little smarter, and I'm sure there's some additional questions. If you have some questions, put them in the comments below. I'll do my best to reply to each and every one of you. In some fashion, I reply to 98%, even if it's just a heart that I read your comment. But put them in down there below. Let's continue the discussion. Ask me any questions you have. Don't forget our promotional. If you want to call in live, so into the studio, so we can do a recording and ask me questions or talk about whatever you want to talk about. Put the word guest in the comments also. You've got to put the word guest, put a nice comment in there of what you'd like me to know, and a like can't hurt. If you didn't like what I did here today, click the dislike button and tell me also. Write it down below. Tell me where I'm wrong and why things aren't the way you think they should be. All right, so I want to thank you. The video's got a little long. I want to thank you and for visiting Digitspin Crypto. Come again. Hit that like button. Hurry up. Hurry up. Hit that like button.
Okay, which one of you sold your Electroneum? I know one of you did this. One of you sold your Electroneum. Was it you, Jackie? I don't know. Was it you, Billy? Billy, did you sell your Electroneum? How about you, Chico? Chico. You sold your Electroneum, didn't you? I know you did.